Let's take a look at the typical annotation track on sorghum. Here it is, Phytosome 12 gene models. The track label shows the track name, the number of annotations on this map, and the date when the track was updated, although you can change this in the settings dialog. When the map is zoomed out, the track displays two histograms of its annotations, one per strand, the direct strand above the axis, and the opposite strand below the axis. These gray rectangles that look like shadows indicate transcripts with orthologs. Let's zoom in a little to view individual annotations. The thick rectangles are exons, and the thin lines connecting them are introns. The herringbone pattern is a reminder of the annotation's strand. In this case, it's on the direct strand, so the 5' end is here, and the 3' end is here. This darker rectangle on top of the annotation indicates its CDS. The annotation track is currently collapsed, so only one annotation per locus is shown in order to save space. You can mouse over the annotation to see a preview of other transcripts in the locus, but it would be better to expand the track, like so. We can also expand or collapse the strands individually from the track's context menu. Using the same menu, we can change the size of the annotation elements. For example, we can make them smaller to save more space on the screen. On some browsers, you can also hold down the Alt key and roll the mouse wheel as a shortcut. At this zoom level, ortholog shadows vary in intensity, with darker shadows indicating more orthologs. Mousing over a shadow displays the exact count of orthologs in its location. Let's zoom in a little further, close enough to see individual nucleotides on the GC content track. Now, the protein translation of each transcript CDS is also revealed. To examine an annotation in detail, click it to bring up the Annotation Details dialog. Note that the annotation will be outlined with a thicker border. This dialog, also known as the gene card, displays two rows of tabs. The Basic Properties tab at the top displays properties that are common to all annotations, such as their prediction method, map, strand, map set, organism, as well as location and CDS coordinates. You can click the names of the map and the map set to open up their own details dialogs. You can also click the eyeball icon next to the map set to reveal it in the map set tree, or click the eyeball icon next to the annotation's location coordinates to zoom in on it and highlight its region on the map. Most annotations also have a specific gene name, but this particular annotation does not. However, we could still identify it by examining its qualifiers here in the bottom tab. These qualifiers contain additional metadata for the annotation, such as its various names, gene functions, and so on. You can quickly search for a particular qualifier by clicking this search button, or define a specific filter for the qualifier's name or value by using these filter buttons. Some qualifiers may contain links to external databases or websites. For example, this qualifier for an annotation on soybean is linked to its gene ontology. In addition to the qualifiers, the bottom row of tabs contains information about the annotation's metrics, as well as a detailed view of all the transcripts for this gene. But we will examine them more closely in another video. The top row of tabs contains information about this transcript's sequences, as well as its orthologs, if any. The Protein tab displays the protein translation of the current transcript's CDS in FASTA format. Fragments of the protein sequence are highlighted in alternating colors, delineating individual exons. You can enter a new value in this text box to adjust the number of characters displayed per line, or click the Auto checkbox to make the sequence fill all of the available space. Text selection inside the protein sequence is synchronized with the Metrics tab, and you can double-click an exon to quickly select it. You can also click this button to copy the entire sequence to the clipboard, or click the Blast button to open the Real-Time Blast dialog, where you can run tblastn to align the protein sequence against your desired genome. The Spliced Sequence tab works in a similar fashion, displaying the transcript's spliced sequence. In this view, UTR exons are displayed in a lighter color. You can also use this checkbox to hide UTRs altogether. Once again, you can use the buttons in the upper right corner to copy the entire sequence, or to use it as a query for BLAST. The Translation tab also displays the transcript's spliced sequence, this time alongside its protein translation. The Unspliced Sequence tab contains the entire unspliced sequence of the transcript. It is color-coded according to the role of each sequence fragment: exons in red, introns in blue, CDS exons on a red background, and poly-N fragments on a sky blue background. In addition, you can use the controls in the upper right to grab some additional sequence upstream or downstream of the annotation. For example, let's grab 100 nucleotides upstream of the annotation. As you can see, they will be colored in green. You can use this button to quickly get rid of both the upstream and downstream fragments. Finally, the Orthologs tab lists all of the annotation's orthologs. You can click the name of an ortholog to display its own gene card, or click the eyeball icon next to an ortholog to open its map and display it alongside the current annotation.